that takes, spiritually, it will be melting sand on one end and putting out fully built AI compute on the other. But we're a long way to go from that. And it's an enormously complex and expensive process. Uh, we are putting a huge amount of work into building out as much compute as we can and to do it fast. And, it's going to be like sad because GPT-5 is going to launch and there's going to be another big spike in demand and we're not going to be able to serve it. And it's going to be like those early GPT-4 days. And the world just wants much more AI than we can currently deliver. And building more compute is an important part of doing that. This is what I expect to turn the majority of my attention to, is how we build compute at much greater scales. So how we go from millions to tens of millions and hundreds of millions, and eventually, hopefully, billions of GPUs that are sort of in service of what people want to do with this.
When you're thinking about it, what are the big challenges here in this category that you're going to be thinking about?
We're currently most limited by energy. Like if you want to run a gigawatt scale data center, it's like a gigawatt. How hard can that be to find? It's really hard to find a gigawatt of power available in short term. We're also very much limited by the processing chips and the memory chips, how you package these all together, how you build the racks. And then there's like a list of other things that are, there's like permits, there's construction work. But again, the goal here will be to really automate this. Once we get some of those robots built, they can help us automate it even more. But just, like a world where you can basically pour in money and get out a pre-built data center. So that'll be a huge unlock if we can get it to work. Second category, data. Yeah. These models have gotten so smart. There was a time when we could just feed it another physics textbook and it got a little bit smarter at physics. But now, like, honestly, GPT-5 understands everything in a physics textbook pretty well. We're excited about synthetic data. We're very excited about our users helping us create harder and harder tasks and environments to go off and have the system solve. But I think data will always be important, but we're entering a realm where the models need to learn things that don't exist in any data set yet. They have to go discover new things. So that's like a crazy new
How
step.
do you teach a model to discover new things?
Well, humans can do it. Like we can go off and come up with hypotheses and test them and get experimental results and update on what we learn. So probably the same kind of way.
And then there's algorithmic design.
Yeah. We've made huge progress on algorithmic design. The thing that I think OpenAI does best in the world is we have built this culture of repeated and big algorithmic research gains. So we kind of, figured out what became the GPT paradigm. We figured out what became the reasoning paradigm. We're working on some new ones now. But it is very exciting to me to think that there are still many more orders of magnitudes of algorithmic gains ahead of us. We just yesterday released a model called GPT-OSS, an open source model. It's a model that is as smart as O4 Mini, which is a very smart model that runs locally on a laptop. And this blows my mind.
Yeah.
Like, if you had asked me a few years ago when we would have a model of that intelligence running on a laptop, I would have said many, many years in the future. But then we found some algorithmic gains, particularly around reasoning, but also some other things that let us do a tiny model that can do this amazing thing. And, those are the most fun things. That's like kind of the coolest part of the job.
I can see you really enjoying thinking about this. I'm curious, for people who don't quite know what you're talking about, who aren't familiar with how an algorithmic design would lead to a better experience that they actually use. Could you summarize the state of things right now? Like what is it that you're thinking about when you're thinking about how fun this problem is?